Caliper or thickness testing is used in product development or quality control to measure the cross-web or down-web thickness profile of plastic film, paper, tissue, and sheeting materials. The Oakland Instrument MX Series microgauges are offline thickness testers placed on a workbench or lab bench where the operator cuts and prepares samples from the production line to run on the system. Models are available that can automatically feed or pull the sample strip through the tester for profiling, or manual models where the strip is hand-fed under the measurement foot for single readings or hand-fed for cross-web readings at multiple locations. Both procedures allow calculation and location of minimum thickness, maximum thickness, average thickness, and other statistics such as standard deviation of thickness data for a given sample. The MX microgauge series utilizes precision LVDT sensors and contact measurement heads to determine the absolute thickness of the material measured. Resolution to 0.01 mil or 0.25 micron, and accuracy to 0.02 mil or 0.5 micron are achievable with the systems. Different contact foot configurations, pressures, and weights are available to match the specific requirements of the materials you are trying to measure. Low foot pressures are utilized if there is a possibility of material compression during the measurement process. All three microgauge models also come standard with parallelism adjustment mechanisms to achieve parallelism better than 40 microinches to ensure measurement accuracy is maintained. Several cycle rates, dwells, drive increments, and measurement units are available to meet your specific needs. The Oakland Instrument Series MX 1210, MX 1200, and MX 1100 microgauge thickness testers are designed to meet the testing requirements of ASTM D6988, Standard Guide for Determination of Thickness of Plastic Film, and TAPI T411, Thickness of Paper, Paperboard, and Combined Board. Testing requirements of ASTM D374, Standard Test Methods for Thickness of Solid Electrical Insulation, are also met by the devices. Oakland Instrument manufactures several thickness tester models that meet the various testing methods specified by ASTM standards. The MX 1100 is a discrete point tester or point-to-point testing with an RS-232 port to allow data collection by leading third-party statistical software packages. The MX 1200 includes onboard statistics which can be displayed on the unit console and can also operate with our Oakland quality control software. The model MX 1210 adds a drive mechanism for automatically pulling sheet samples for thickness profiling. Our model MX 1300 quality control software records, graphs data, calculates statistics values, and provides reports for quality control record keeping. Film samples are cut to approximately 125 millimeter or 5-inch wide. Film is defined as sheeting having a thickness of not greater than 0.25 millimeter or 10 mil, as indicated by ASTM standard D6988. A sheeting specimen greater than 0.25 millimeter thickness up to approximately 300 mil or 7,620 micron can be measured with the system depending on hardware configuration. Sheeting specimens should be flat and free of creases and defects to assure optimum accuracy. Material creases should be hand-fed around to avoid the sensor during the measurement cycle. Record the direction in which readings are taken, cross-web or transverse direction, or down-web or machine direction. One specimen is typically prepared to run per roll of material produced. Care must be exercised when handling sample specimens. The test surface must be kept free from external damage or from foreign matter that may change the surface characteristics of the specimen and be measured in error. Plastic films and sheeting may exhibit different thickness properties in their respective principal directions due to extrusion effects. Specimens may be tested with their long dimension in either the machine or transverse direction, but it is common practice to test specimens with its long dimension perpendicular to the machine direction. To measure samples from the leading edge with the MX 1210 profiling microgauge, you can tape a leader to the beginning of the sample and place the leader under the drive wheel to begin the sample measurements at the sample edge. Tape the approximately 5-inch or 125 millimeter long leader to the leading edge of the sample strip. Place the sample or sample leader under the drive wheel by pressing and releasing the lower spring-loaded idler wheel. Start the drive mechanism to start the test and begin data collection. Stop the drive mechanism at the end of the sample to stop data collection. Depress the red push button labeled Average at the end of the test to display thickness profile statistics including average, standard deviation, high, low, and count or number of data points taken during the test. Average, standard deviation, high thickness, low thickness, count. Depress the white push button labeled Clear after recording or printing your data to clear the firmware memory for the next test. Or, if you prefer to run more than one sample segment and combine the data into a single data file, simply restart the drive mechanism and the new data will be added to the resident file data. A serial ticket printer can be connected to your MX series microgauge for ticket data reporting of thickness points and summary statistics. simply connect the configured serial ticket printer to your microgauge. All data that is transmitted to the digital display on the gauge console is also transmitted serially from the RS-232 connection on the back panel of your microgauge. Place the sample or sample leader under the drive wheel by pressing and releasing the lower spring-loaded idler wheel. Open your Oakland MX1300 quality control software and press the Start Test button labeled SPC on the main screen. Start the drive mechanism to start the test and begin data collection. Stop the drive mechanism at the end of the sample to stop the data collection. Depress the Stop Test button on your MX1300 quality control software to display the thickness profile on the main screen. The MX1300 quality control software allows you to view thickness profiles in either linear graph or polar graph styles for blown film annular extrusion dies, plus a variety of statistical screens including Fourier analysis. During the test, record your data on a standard data form or collect data to ticket printers, third-party statistical software, or Oakland's MX1300 quality control software package. Your MX1300 quality control software also allows you to export data to any ASCII format software, including Microsoft Excel, Minitab, and Hertzler systems. If following ASTM or other standards, you are typically required to record product description, sample conditioning procedure followed, instrument configuration and setup, testing technique used, specimen nominal thickness, principal directions tested, approximate age of sample after manufacture, date and operator name, average thickness and thickness range, together with the standard deviation and number of specimens tested for each caliper. After recording the test data, determine and report the calculated high and low thickness values, range, average, together with the standard deviation. Other useful reported values include range as a percentage of average and deviation as a percentage of average or target. Comparisons to preset upper and lower control limits are also useful for keeping your process within control. All of these are automatically calculated and reported by your MX1300 quality control software. The thickness and length values stated in SI units are regarded as the standard. Units can be reported in metric, English, or International System values. Oakland Instrument provides standard data forms with its testers, which can either be filled out manually or used in a computer-assisted manner with third-party statistical software packages such as Microsoft Excel. Oakland Instrument also offers quality control software packages for caliper or thickness data collection and reporting that meets the standards.